Hi everyone, today we are going to study the numericals of chapter 8b. In that question number 1, here in the question you can see diagram figure number 8.42. First I will explain the diagram. Here you can see a cell of epsilon. EMF is given 2 volt and the internal resistance is 1 ohm. And you can see a voltmeter connected in parallel to the cell, and there is an extra resistance of 4 ohm, and it is connected to an ammeter through a key. So here the question is, you are asked to calculate the reading of the ammeter and voltmeter when the key is open and when the key is closed. So the first question, the diagram shows a cell of EMF 2 volt. So epsilon EMF is given 2 volt and internal resistance small letter R 1 ohm connected to an external resistance 4 ohm. External resistance capital letter R is 4 ohm. The ammeter measures the current in the circuit and the voltmeter measures the terminal voltage across the cell. What will be the reading of the ammeter and voltmeter when key is open, key is closed? So first we are going to calculate when the key is open. Open means open circuit, the current will not flow. You all know that. So what will be the reading in the ammeter? 0, because there is no current. You know what is an ammeter? Ammeter is an instrument which measures current in the circuit. Since the circuit is open, no current flows through the circuit, so ammeter reads 0 volt. And what will be the reading of the voltmeter? What is a voltmeter? Voltmeter is a device which measures potential difference across the terminals. Again here, since it is open, so the potential difference or the voltmeter is the voltage of the cell alone. Since it is open, so the voltage of the cell or EMF is already given, it is 2 volt. EMF of the cell is given 2 volt. Now second part is, you have to find the reading of the ammeter as well as voltmeter when the key is closed. Key closed means current start flowing, so there will be resistance in the circuit. So here we are going to calculate closed circuit. I is equal to epsilon by R plus R. We have the formula. This formula is in the textbook. Current is equal to EMF divided by total resistance, external resistance plus internal resistance. Substitute 2 by 4 plus 1, 2 by 5 is 0.4 ampere. Now you have to calculate the voltage across the terminals if it is open. So we don't have the direct formula for voltage. We have the formula R is equal to, we are studying so many formulas in your textbook. Equation number 8.28. You are asked to study all the formulas under that equation 8.28. In that you can see R is equal to, internal R is equal to epsilon minus V by I. Now just cross multiply, you will get IR is equal to epsilon minus V. Now again minus V coming to this side, it will become, minus V to this side and IR to other side. So you will get V is equal to epsilon minus IR. Now direct substitution, epsilon is equal to I into R, that is 2 minus 0.4 into 1, you will get 1.6 volt. Next question number 2. A battery of EMF 3 volt. So epsilon, EMF epsilon is given 3 volt, supplies current through a circuit in which resistance can be changed. A high resistance voltmeter is connected across the battery. When the current is 1.5 ampere, the voltmeter reads, voltmeter reads 2.7 volt. Find the internal resistance of the battery. So this is direct question. You just want to find the internal resistance R. R is equal to epsilon minus V by I. Direct substitution 3 minus 2.7 by 1.5. You will get the answer 0.2 ohm. Question number 3. In that you can see the diagram is given in the question, figure 8.43. Here you can see a cell, the voltage EMF of the cell is 1.8 and the internal resistance is written near to that cell. Whenever you see a resistance 2 ohm or any resistance near to the cell, it means it is internal resistance. So EMF is given, internal resistance is given, and there is one more resistance. There is ammeter. You can see the ammeter. Near to the ammeter also you can see 0.7 ohm. That means ammeter consists of coils and that coil offers some resistance. So here ammeter resistance is given 0.7 and a normal resistor is given 4.5. Since they are connected in series, the total external resistance we can just add up 4.7 plus 0.7. 4.5 plus 0.7, you will get 5.2 ohm. That will be the external resistance. R is the internal resistance. 1.8 is the epsilon EMF. We are asked to calculate current in the circuit and voltage, or what does ammeter reading and the voltmeter reading. So I is equal to epsilon by R plus R. Epsilon is given 1.8, R plus R, 2 plus 5.2. So 1.8 by 7.2 you will get the answer 0.25. Next you are asked to calculate V. We don't have the direct formula for V. We have the formula R. R is equal to epsilon minus V by I. Just cross multiply. Substitute the values. 2 is equal to 1.8 minus V by 0.25. Now cross multiply. 2 into 2.5 you will get 0.5. 0.5 is equal to 1.8 minus V. Minus V to right hand side. 0.5 to left hand side. So you will get V is equal to 1.8 minus 0.5. You will get the answer 1.3 volt. Next question number 4. A battery of EMF 15 volt. So EMF is given 15 volt. Internal resistance R 3 ohm is connected to two resistors in series. 3 ohm and 6 ohm in series. So when you are doing the problem, when two resistors are connected in series, just we need to add it. So 3 plus 6, 9 ohm. So the external resistance is given 9 ohm. Find the current through the battery and the potential difference between the terminals. So current I is equal to epsilon by R plus R. 15 by, this is 9, external resistance, internal resistance, 9 plus 3. So 15 by 12 you will get 1.25 ampere. Second one, potential difference. Potential difference B. So we have to find small letter R. Internal resistance R is equal to epsilon minus V by I. Substitute the values, just cross multiply, and when we take it, arrange the values, you will get the answer. Voltage V is equal to, or potential difference is equal to 11.25 volt. Now question number 5. A cell of EMF epsilon and an internal resistance R sends current 1 ampere when connected to an external resistance 1.9 ohm and sends current 0.5 ampere when connected to external resistance 3.9. So if the current is 1 ampere, the current will be 1 ampere if the resistance is 1.9 ohm. And the second case, there we are considering two cases. Second case, the current is only 0.5 ampere if the resistance is 3.9 ampere ohm. So you can see when the resistance increases, current decreases. So two cases are given. We are asked to calculate epsilon and internal resistance R. So I is equal to epsilon by R plus R. We are taking the ratio, two sides both. So I is equal to epsilon by R plus R. Here also I is equal to epsilon by R plus R. Substitute the values. Here I is 1. 1 is equal to epsilon by 1.9 plus R. This is 1.9 and R we don't know. Here also 0.5 is equal to epsilon by 3.9 plus R. Just to cross multiply. So you will get epsilon is equal to 1.9 plus R. And here also just to cross multiply and change the bracket. Epsilon is equal to 0.5 into 3.9 plus R. So here since LHS are same, epsilon is equal to epsilon. LHS are same, we can equate the RHS. So 1.9 R is equal to, after changing the bracket you will get 1.95 plus 0. R. So finally we got R as 0. Just calculate this one, rearrange, you will get internal resistance is 0.1 ohm. Now we have to calculate epsilon also. So you just substitute R is equal to 0.1 in any of this equation. In any equation you substitute, you will get the answer. So since this is easy one, I am going to substitute here. Instead of R, I am going to substitute 0.1. So 1 is equal to epsilon by 1.9 plus R. So epsilon is equal to cross multiply 1 into 1.9 plus R. This 1.9 plus 0.1 here. Resistance is 0.1. So 0.1. So 1.9 plus 0.1, you will get epsilon 2 volt. Next we are going to do with a different type of question, like the combination of resistance. So keep in mind, when the resistance are connected in series, to find the total resistance, just add it. Add the resistance. If the resistance are connected in parallel, then we have to take the formula 1 by Rp. Rp means resistance in parallel equals 1 by R1 plus 1 by R2 plus 1 by R3. So we are calculating 1 by Rp. So generally the children used to make mistake. They forget to take the reciprocal while calculating Rp. So these are the simple way, simple problem. So in that question number 1, question number 6 is 2 resistors having the resistance 6 ohm and 4 ohm are connected in parallel. Find the equivalent resistance. So this is the diagram of parallel connection. How will you draw parallel lines? The same way parallel connection 4 ohm and 6 ohm. Calculate the equivalent resistance. So we have the formula 1 by Rp equals 1 by R1 plus 1 by R2. R1 and R2 we can directly substitute the formula 1 by 4 plus 1 by 6. So 1 by Rp is just a cross multiply 6 plus 4 by 6 into 4, you get 10 by 24. Once you reach this, you please don't want to reduce it or convert it into decimal, because here we are calculating 1 by Rp. Equivalent resistance is Rp. So here we have to take the reciprocal. Rp by 1. 1 by Rp. Rp by 1. Just take the reciprocal. So 10 by 24 will become 24 by 10. Rp by 1 means it is Rp. Resistance in parallel. You will get 2.4 ohm. Next question number 7. 4 resistors. Each of resistance 2 ohm are connected in parallel. What is the effective resistance? So you can see 4 parallel lines. 4 parallel resistance. Each 2 ohm. Calculate the equivalent resistance. So 1 by Rp equal 1 by 2 plus 1 by 2 plus 1 by 2 plus 1 by 2. Since the denominators are same, we can just add the numerators. So 1 by Rp is 4 by 2. As I told, don't forget to take the reciprocal. 1 by Rp, taking reciprocal, Rp by 1 is 2 by 4. 2 by 4 is 1 by 2. Then you can take the decimal 0.5. Rp by 1 means Rp itself. So it is 0.5 ohm. Next question number 8. You have 3 resistors, 2 ohm, 3 ohm and 5 ohm. How will you join them so that the total resistance is less than 1? Draw the diagram and find the total resistance. So 3 resistors are given. Like you are studying probability in maths, you have only one specification. The total resistance should be less than 1. How will you connect these resistors? So you know, if you are trying to connect all the resistors in series, what will be the total resistance? 2 plus 3 plus 5, you will get 10 ohm. So it is a wrong answer. Suppose I am connecting one resistor in series, another in parallel. Anyhow, here we will get a particular value. Never mind. But this parallel combination is connected with the series. So the final answer will be 2 plus this value. 1 by 3 plus 1 by 5. 2 plus. That means the value will be always greater than 1. If you are taking 3 ohm here also, anyhow, If there is a series connection, we have to add that value to the parallel. So the final answer will be more than 1. So only one possibility remaining is all the 3 resistors should be connected in parallel. So you have to draw the diagram clearly, because the diagram is one of the question. Draw the diagram. So you have to draw the diagram. Here you have to write 2 ohm, 3 ohm, 5 ohm. So 1 by Rp is equal to 1 by 2 plus 1 by 3 plus 1 by 5. Take the LCM. LCM is 30. 3 into 2, 6. 6 into 5, 30. LCM 30. So I think you all know how to convert this 1 by 2 to make all the denominators same. So 1 by 2 will become 15 by 30. 1 by 3 is 10 by 30. And 1 by 5 is 6 by 30. If you want, you can do by finding the LCM, or else first you can cross multiply these two values and finally you will get the one value to that, again cross multiply. Any method, we are studying maths, how to change the proper fraction and all. So you can adopt any method. Finally you will get 1 by Rp is 31 by 30. So reciprocal. Again I am not going to write Rp by 1. It is understood. Rp by 1 is Rp. Rp is equal to 30 by 31. Divided, you will get the answer 0.967 ohm. Next question number 9. 3 resistors, each of 2 ohm, are connected together. So the total resistance is 3 ohm. Draw a diagram to show the arrangement and check it by calculation. So 3 resistors are given 2 ohm. The total resistance should be 3 ohm. So if you are connecting in parallel, in series, 2 plus 2 plus 2, it will be 6 ohm. So it will not be the correct answer. So the second option will connect 1 ohm. If you are connecting all the 3 resistors in parallel, what will happen? 1 by 2 plus 1 by 2 plus 1 by 2. You will get 3 by 2, taking the reciprocal 2 by 3. So the answer will be again less than 1. So here we have the third option, 1 in series, 2 in parallel. So we have to look which option will be correct. Final answer is given, it should be 3 ohm. So here we will get 2 ohm plus 2 ohm. This is connected in parallel. So 1 by 2 plus 1 by 2, you will get 2 by 2. That is 1. 1 by Rp is 1. So Rp is also, well, taking the reciprocal. 1 reciprocal is 1 ohm. So we have to redraw the diagram. Here it is 2 ohm, 2 ohm. This parallel combination, finally we got it as 1 ohm. So here again 1 ohm. Instead of these two, rearrange the diagram to 1 ohm. So total 2 plus 1, 3 ohm. Our answer is fulfilled. Next, question number 10. Calculate the equivalent resistance between the 2 points A and B if each resistor is 2 ohm. So this is the diagram given in your textbook. Here you can see these two are connected in parallel. So first we have to find the parallel series. 1 by Rp equals 1 by 2 plus 1 by 2. 2 by 2, that is 1. So Rp reciprocal is again 1 ohm. 1 by 1 is 1. So instead of this, you should redraw again 2 ohm, 2 ohm, again 2 ohm, 2 ohm. Instead of this, 1 ohm, we got Rp is 1 ohm. So 2 plus 1, we got the equivalent resistance, total resistance 5 ohm. Okay. Next, question number 11. A combination consists of 3 resistors in series, 4 similar sets. 3 resistors in series, the same similar set, 4 sets. So you can see first set, second set, third set, fourth set. I repeat, a combination consists of 3 resistors in series, 4 similar sets are connected in parallel. If the resistance of each resistor is 2 ohm, find the equivalent resistance. So what we have to do first is, these are connected in series. So just redraw the diagram. 2 plus 2 plus 2, 6 ohm. So the compressed diagram is 6 ohm, 6 ohm, 6 ohm, 6 ohm. All are connected in parallel. Now you calculate the equivalent resistance. 1 by Rp equals 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. So you will get 1 by Rp is 4 by 6. Take the reciprocal. Don't forget to take the reciprocal. Rp by 1 or Rp is equal to 6 by 4. You will get the answer 1.5 ohm. Next, question number 12. Already in the question the diagram is given. In a circuit shown in figure 8.45, calculate the value of X if the equivalent resistance between the point A and B is 4 ohm. So equivalent resistance is already given 4 ohm. And here in the textbook it is two resistors are there, 4 ohm and 8 ohm. Since they are in series, I just add it and draw it together. So it is 12. Altogether it is 12. So here this 12 ohm and these are connected in parallel and the equivalent resistance value is directly given. We are asked to find the value of X. So 1 by Rp is equal to 1 by 12 plus 1 by. Why I took X plus 5? Because these two are connected in series. Since we don't know the value of X, we have to write X plus X. Okay, 1 by Rp is equal to 1 by R1 plus 1 by R2. The same formula, since it is X, I can add this. So just write here 1 by X plus 5. So Rp value is already given, final resistance. So 1 by 4 is equal to 1 by 12 plus 1 by X plus 5. Now 1 by 12 plus 1 by 12 take into other side, it will become minus. So 1 by 4 minus 1 by 12 equals 1 by X plus 5. You know how to solve this equation. Here you can cross multiply and 12 minus 4 by 12 into 4 is equal to 1 by X. Then you solve it, you will get the final answer. X is equal to 1 ohm. Next, question number 13. Calculate the effective resistance between the point A and B in the circuit shown in figure 8.46. So this is the figure given in your textbook. Here 1 ohm, 1, 1, 1. Here 2 ohm, 2, 2, 2 and 1 ohm. So first what we have to do is we have to rearrange it. For that we should know how to take the resistors in series and parallel. Now here you can see a joining. From here when you draw a straight line, a continuous line, not a straight line, continuous line. From here it will end the continuous line till here. So these three we can consider as connected in series. So 1 plus 1 plus 1, 3 ohm connected in series. The same way from the junction, always look the junction. From the junction towards downward. These three are connected in series. 2 plus 2 plus 2. From the junction till the next junction only will be considered as series connection. So I just rearrange this diagram to this diagram. So here this 1 ohm remains 1 ohm. 1 plus 1 plus 1, 3 ohm. I wrote here 3 ohm. And in the middle it is 2 ohm. No change for the 2 ohm because this is the junction. So that 2 ohm remains that 2 ohm. Then these 3 2 ohms I wrote here as 6 ohm. Now here again 1 ohm is there, let it be there itself. Now we got these 3 resistors are connected in parallel. So first we have to consider the equivalent resistance, equivalent parallel resistance. So 1 by Rp is equal to 1 by 3 plus 1 by 2 plus 1 by 6. If you want, you can take the cross multiply and do, or take the LCM is 6. Then changing the denominator, same denominator, by considering the LCM, you will get 2 by 6 plus 3 by 6 plus 1 by 6. 6 by 6 you will get 1 ohm. So all these three together we got 1 ohm. Now again compress the diagram. You will get first it is 1 ohm, last is 1 ohm. Instead of these three parallel we got again 1 ohm. So 1 ohm plus 1 ohm plus 1 ohm. We will get the total resistance is 3 ohm. Next question number 14. A uniform wire with a resistance 27 ohm is divided into 3 equal pieces. That is 27 ohm is divided into 3 pieces of equal pieces and they join in parallel. Find the equivalent resistance of parallel combination. So a single wire, the total length of the wire is divided into 3. Total resistance is 27. So if it is divided into 3 pieces, then what will be the resistance of each piece? It will be 9 ohm. You know 27 divided by 3 is 9 ohm. So these 3 wires are connected in parallel. draw the diagram. You have to draw the diagram neatly. 9 ohm, 9 ohm, 9 ohm connected in parallel. Calculate the equivalent resistance. 1 by Rp is equal to 1 by 9 plus 1 by 9 plus 1 by 9. That is 3 by 9. 1 by Rp is 3 by 9. Rp by 1 is 9 by 3. You will get the answer 3 ohm. Next question number 15. A circuit consists of a resistor of 1 ohm in series with the parallel arrangement of 6 ohm and 3 ohm. Okay, 1 ohm series with parallel combination of 6 ohm and 3 ohm. Calculate the equivalent resistance and draw the diagram. So for drawing this diagram, you will get 1 mark and doing the problem. So what we have to do first, always consider the parallel connection. 1 by 6 plus 1 by 3. Cross multiply, you will get Rp is equal to 18 by 9. That is, finally we got 2 ohm. 1 by 6 plus 1 by 3. After taking the reciprocal, you will get it is 2 ohm. Now here already 1 ohm is there, series. So 1 ohm and 2 ohm. Instead of this parallel, we got a single resistance 2 ohm. Just add it, 1 ohm plus 2 ohm connected in series. Total resistance R is equal to 3 ohm. Next question number 16. Calculate the effective resistance between 2 points A and B from the figure given below. So in the textbook you can see here 2 ohm. These 3 resistors are connected in parallel, 12, 6 and 4 and 5 ohm. So first go for the connection in parallel, 1 by 12 plus 1 by 6 plus 1 by 4. Take the LCM for 12. So rearrange it, you will get 1 by Rp is equal to 1 by 12 plus 2 by 12 plus 3 by 12. I am just calculating the LCM and making it as a common factor. So finally you get 6 by 12. 1 by Rp is 6 by 12. Rp 1 by is 12 by 6. That is 2 ohm. So instead of this portion, we got it as 2 ohm. Now redraw the diagram. 2 ohm. This we got again 2 ohm. And again here 5 ohm. So 2 plus 5. You will get 9 ohm. Next, question number 17. Again you can see this diagram in your textbook. You are asked to calculate the equivalent resistance between A and B. Here you can see the junction. This is one junction and this is another junction. So we can consider from one junction to another junction. Draw a arch. So these 3 and 2 are connected in series. So we just want to add 3 plus 2, 5. So instead of these 2 resistors, I am drawing here only one resistor because 2 and 5, again there is no any junction. This is just a curve. So 3 plus 2, 5 ohm. Now this 30 ohm, let it be 30 ohm again. Again from the junction towards bottom, again this is just a curve. Don't consider this as junction. If 3 or more resistors are joining, then only it is considered as junction. This is not a junction. So 6 plus 4, 10. So now we got the second diagram. When you are solving, this diagram carries mark, compressed diagram. So here we will get 5 ohm, 30 ohm, 10 ohm. Now it's the matter of substituting in the substituting the formula. 1 by Rp is equal to 1 by 5 plus 1 by 30 plus 1 by 10. Taking the LCM, you will get 1 by Rp is equal to 6 by 30 plus 1 by 30 plus 3 by 30, 10 by 30. Taking reciprocal, Rp is equal to 30 by 10. You will get the equivalent resistance is 3 ohm. Next question number 18. In the network shown in figure 8.49, calculate the equivalent resistance between the point A and B and A and C. So this is the diagram given in your textbook. Here A, B, C, D are the points. First question is calculate the equivalent resistance between A and B. So we have to mark it. The junctions mentioned here is A and B. So from this junction we have to draw a circle, draw an arc. So 2 plus 2 plus 2. From one junction till another junction is considered as resistors connected in series. So we have to redraw the diagram. From A, just drawing a line, till B. One junction to next junction. 2 plus 2 plus 2. since they are connected in series, you will get 6 ohm. Then here it is 2 ohm again as a connected in parallel. So this diagram I can redraw like 6 ohm and 2 ohm. This all together 6 ohm and this 2 ohm. Now we have the to substitute in the formula. 1 by Rp is equal to 1 by 6 plus 1 by 2. You will get 8 by 12. Now Rp by 1 is equal to 12 by 8. You will get the answer 1.5 ohm. In the same question, you are asked to calculate the equivalent resistance between A and C. So we have to change the junction from junction is from A and C. So from one junction to another junction, 2 plus 2, these two are connected in series. And again from this junction to this junction, again 2 plus 2 connected in series. So I can rearrange the diagram as this is parallel. Between two junctions is considered as parallel. From the junction above the junction 1 resistor, below the junction 1 resistor. So 4 ohm and 4 ohm. Okay. This 2 4 ohm, this 2 4 ohm, this is the junction. So this is connected in parallel. Now 1 by 4 plus 1 by 4, you will get 2 by 4. 1 by Rp is 2 by 4. So Rp by 1 is 4 by 2. You will get the answer 2 ohm. Next question number 19. 5 resistors each of 3 ohm are connected as shown in figure. Calculate the resistance between the points P and Q and X and Y. So here you can see the diagram and you are asked to calculate the resistance, equivalent resistance between P and Q as well as X and Y. So first we will consider P and Q, the junction P and Q. So how is it connected? From P to Q. So 3 and 3 are in series. Just we need to add 3 plus 3 is 6. And it is in parallel with this 3. So we can rearrange the diagram to here. Here it is 3 itself. Instead of this 3 plus 3, I wrote here 6. So 6 and 3 are in parallel. Now substitute in the formula. 1 by Rp is equal to 1 by 6 plus 1 by 3. Cross multiply, you get 9 by 18. 1 by Rp is 9 by 18. So Rp by 1 or Rp is 18 by 9. You will get 2 ohm. So that is the first answer. Equivalent resistance between PQ. We got as 2 ohm. Now again we are rearranging. Here 3. Here 3. Instead of this portion we got as 2 ohm. So equivalent resistance between X, Y. Here is X, here is Y. Instead of this I draw here 2 ohm. So 3 plus 2 plus 3. You will get the final answer. Equivalent resistance between X and Y is 8 ohm. Okay. Next question number 20. Two resistors 2 ohm and 3 ohm are connected in series in parallel with a battery 6 volt of negligible internal resistance. For each case, draw the circuit diagram and calculate the current through the battery. So 2 resistors are given. First we are considering 2 resistors are connected in series and these 2 resistors are connected with a battery of 6 volt. We have to find the current passing in this circuit. So voltage is given 6 volt. Resistance, since these are connected in series, we have to add 2 plus 3, 5 ohm. We have the formula according to Ohm's law. V is equal to IR. I is equal to V by R. 6 by 5. You will get 1.2 ampere. Current in this circuit will be 1.2 ampere. Now the same diagram. If these two resistors are connected in parallel instead of series, I am connecting parallel. What will be the current in this circuit? So 1 by Rp is equal to, since it is parallel, 1 by 2 plus 1 by 3, cross multiply, you will get 5 by 6. So Rp is equal to 6 by 5. You will get the resistance in the circuit is 1.2 ohm. Voltage is fixed. It is given from the battery. It is 6 volt. Resistance we got it as 1.2 ohm. So final current I is equal to V by R. 6 by 1.2. Just multiplying by 10 to remove the decimal. You will get 60 by 12. That is 5 ampere. Next question number 21. A resistor 6 ohm is connected in series with another resistor 4 ohm. So series connection. 6 ohm and 4 ohm in series. a potential difference of 20 volt is applied across the terminal. So potential difference means a battery is connected and the potential difference or voltage of the battery is given 20 volt. Calculate the current in the circuit and the potential difference across 6 ohm resistor. So we have to first calculate the current. Current I is equal to, current is I. I is equal to V by R. V is already given 20 volt. R means these are connected in series. So we just want to add it. R is equal to 6 plus 4, 10 ohm. So directly we can calculate V by R is equal to 20 by 10, that is 2 ampere. Second question is potential difference across 6 ohm. What will be the potential difference when you are connecting a voltmeter over here? So for finding potential difference across 6 ohm resistor, potential difference formula V is equal to IR. We already calculated I is 2 ampere. Across 6 ohm, they are specifying across which resistor. So that resistance we need to write here. So 2 into 6, 12 volt. Next question number 22. Two resistors of resistance 6 ohm and 4 ohm are connected in parallel to a cell to draw 0.5 ampere from the cell. Draw the diagram. So two resistors are there, 4 ohm and 6 ohm, they are connected in parallel, connected to a cell which draws a current 0.5 ampere. We are asked to draw the diagram, so this drawing the diagram carries mark. And we are also asked to calculate current in each resistor. We have to calculate current in each resistor. So first we have to calculate the total voltage or potential difference. Since the resistance are connected in parallel, we have to calculate the total resistance. It is parallel. 1 by Rp is equal to 1 by 4 plus 1 by 6. So 1 by Rp, I think we completed around 20 numericals. You know how to take cross multiply and calculate the final answer. So 1 by Rp will get 10 by 24. Taking the reciprocal, we will get Rp is equal to 2.4 ohm. So the entire circuit we got resistance is 2.4, current is 0.5. So what will be the voltage or potential difference? V is equal to IR. Current is 0.5. R we got 2.4. So we got in this entire circuit the potential difference is 1.2 volt. Now the second question is calculate the current through each resistor. We have to calculate. Suppose a current, this 0.5 ampere, the current I1 is passing from here, from 0.5 ampere, the current I, here you can see I, current passes through this circuit and reaches here, this is I. When it is connecting to a parallel circuit, it splits into two, I1 and I2. Current will get split into I1 and I2, and when it exit, again it will become I. Okay, so here they are asking how much current will be passed through 4 ohm and the same way how much current will be passed through 6 ohm. This I gets splitted. So we have to calculate that. For that we have current through 4 ohm resistor. Formula for current I is equal to V by R. Voltage always remains constant in this case. So V by R 1.2 by 4. We get 0.3 ohm. And current through 6 ohm, I 6 ohm is equal to V by R, that is 1.2 by 6, 0.2. So if you want, you can just check whether the answer is correct or not. Here the total current is 0.5 ampere reaches here. It's split into 2 and we got through 4 ampere it is 0.3 and here it is 0.2. 0.3, 0.2. When you add it, what will happen? 0.3 plus 0.2, again we will get 0.5. So we can say that our answer is correct. So we can check the answer whether the answer is correct or not. This 0.5 split to 0.3 and 0.2. So if we add 0.3, 0.2, we should get 0.5. Okay. Next question number 23. Already diagram is given in the question. In that question you can see two resistors, 1 ohm and 2 ohm. Calculate the current flowing through each of the resistors A and B. So formula voltage is IR, or from that I is equal to V by R. Voltage is already given in the figure, it is 2 volt, and resistance. Question is calculate the current flowing through each resistor. So current in first resistor or B. B is 2 ohm. You please look in a textbook, figure number 8.51. You can see B resistor is of 2 ohm. So V by R, voltage is 2, resistance is 2. So current is 1 ampere, 2 by 2. Now current through first resistor A. Resistor A is 1 ohm. So voltage by current 2 by 1 will get 2 ampere. Next question number 24. Question number 24 also the diagram is clearly given. In that diagram you can see a voltmeter, and the voltmeter is reading 4 volt, and there is an ammeter which measures the current is 0.4 ampere, and 2 resistance are there, 20 ohm and one more resistance R, that is unknown resistance R. So we are asked to calculate the total resistance of the circuit. So first we can calculate the total resistance. If we have voltage and current, we can, without using finding any resistance parallel or series, we can directly calculate the resistance. If and only if current and voltage, voltmeter reading and ammeter reading are provided. So R is equal to V by I. Voltmeter is 4 volt and ammeter is 0.4. So we got 10 ohm. That is a total resistance. Second question is calculate the value of unknown resistance R. Here you can see that 2 resistors are connected in parallel. One resistance is 20 ohm, second resistance is R. We don't know what is R. So we have the formula. Since they are connected in parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2. 1 by Rp, resistance in parallel, total resistance. We already got the total resistance, that is the resistance in parallel. So 1 by 10 is equal to 1 by 20. This 20 ohm is already given in the figure. And we have to calculate this unknown resistance R. So this 1 by 20 when it goes to the other side, LHS, it will become negative 1 by 20. So 1 by 10 minus 1 by 20 is equal to R. So 1 by R, the same. When you cross multiply, you will get 1 by 20. 20 minus 10. 10 by 200, cancelling 1 0. 1 by 20. So R, unknown resistance is 20 by 1. You will get 20 ohm. There is one more sub question, question number 24. Calculate the current flowing in R. Current through R. I is equal to V by R. Voltage is already given 4. And R, why we took this 20? Because we already calculated the unknown resistance is 20 ohm. That is why we took here 20. So 4 by 20 is 0.2 ampere. Question number 25. A particular resistance wire has a resistance of 3 ohm per meter. Per meter means 1 meter. If the wire is 1 meter, resistance is 3 ohm. Okay, that's the only concept given in the question. A particular wire is there, the length of the wire is 1 meter. If the length is 1 meter, resistance is 3 ohm. It is fixed. Find the total resistance of 3 lengths of this wire, each 1.5 meter long, joined in parallel. So we are going to take 3 wires, the same material, 3 wires, but each wire is 1.5 meter long. Okay, so 1.5 meter long, 1 meter is 3 ohm. So what will be 1.5 meter? Just multiply 1.5 into 3, you will get 4.5 ohm. So we are going to take 3 similar wires of length 1.5 meter. And those 3 wires are going to connected in parallel. So this is the second diagram. So this is 1.5 meter, 1.5 meter, 1.5 meter. 1.5 meter have resistance 4.5 ohm. That is why I wrote here 4.5 ohm. Now we are asked to calculate the equivalent resistance when they are connected in parallel. So what you have to do? 1 by Rp, resistance in parallel equal 1 by 4.5 plus 1 by 4.5 plus 1 by 4.5. Denominators are same, we can add the numerator. So 1 by Rp is 3 by 4.5. Taking the reciprocal, Rp by 1, that is Rp is equal to 4.5 by 3. You will get the answer 1.5 ohm. Then here the second sub question B. The potential difference of the battery which gives a current 2 ampere. Find the potential difference. If the current is 2 ampere. Suppose the voltage is, okay, current is 2 ampere. If the current is given 2 ampere, you are asked to calculate the potential difference. The potential difference of the battery which gives a current 2 ampere in each of the 1.5 meter length. You are asked to calculate only in one length, 1.5 meter length, what will be the voltage. So V is equal to IR. Current is given in the question 2 ampere and R, resistance. Why I took 4.5? Here they specify potential. Find the potential difference of the battery which gives a current 3 ampere in each of the 1.5 meter length. So each we have to take only one resistance. So 2 into 4.5 you will get 9 volt. Now third sub question. Find the resistance of 5 meter length wire of the same material but with twice the area of cross section. So we already know 1 meter is 3 ohm. So what will be 5 meter? 15 ohm. 5 into 3, 15 ohm. So instead of 1 meter, here we are going to take a wire of 5 meter length. So it will be obviously 15 ohm. And here one twist is there, but with twice the area of cross section. Twice the area. Area increases. What will happen to resistance? Resistance decreases. Area doubled. Twice means doubled. When area doubled, resistance will get half. So what is the half of 15? 7.5. So the new resistance will be 15 by 2. You will get 7.5 ohm. Next, question number 26. A cell supplies a current 1.2 ampere. So this is the cell. Cell supplies a current 1.2 ampere through two resistors, each of 2 ohm, connected in parallel. So if the 2 resistors are connected in parallel, the current through the circuit is 1.2 ampere. If the same resistors are connected in series, you can see the current through the circuit is 0.4 ampere. This is also given in the question. When the resistors are connected in series, it supplies a current 0.4 ampere. Calculate the internal resistance of the cell and EMF of the cell. So for calculating the current, first what we have to find? We have to find the resistance of each circuit. Since they are connected in parallel, 1 by Rp is equal to 1 by 2 plus 1 by 2, 2 by 2 is equal to 1 ohm. So the entire resistance is 2 ohm. And here the resistance is 2 plus 2, 4 ohm. So resistance in series is 4 ohm. So here we got the total resistance is 1 ohm and current is 1.2. Okay, resistance and current is not. We have to calculate voltage. And in this case also resistance and current is not. We have to calculate voltage. If a current is passing from a cell, a particular cell will have a fixed voltage. So voltage will be same. So on the basis of that criteria, we are going to continue with the problem. So we are asked to calculate internal resistance, small letter r, and epsilon, EMF of the cell. As I already told, voltage is I into R plus R. Here they are specifying internal resistance. Otherwise, what is V is equal to IR, that much enough. But here they are specifying internal resistance. So V is equal to IR. R here means R plus R. External resistance plus internal resistance. So here we are considering resistance in parallel. Here the same way resistance in series. V is equal to I into R plus R. As I already told, voltage remains constant. So left hand side are same. We can equate the RHS. I into R plus R equal I into R plus R. This is parallel combination. This is series combination. So in parallel combination, current is already given 1.2 and parallel resistance we got it as 1. R is equal to, in series combination, current is 0.4 and combination of two resistance in series, 2 plus 2, 4 ohm plus R. So just change the bracket, 1.2 into 1, 1.2 plus 1.2 R equals 0.4 into 4, 1.6 plus 0.4 R. Now the R, this R is taking to LHS side. So 1.2 R minus plus 0.4 R taking to LHS, it will become minus 0.4 R is equal to 1.6. Positive 1.2 taking to other opposite side, it will become minus 1.2. 1.2 R minus 0.4 R. 1.2 minus 0.4, you will get 0.8 R is equal to 1.6 minus 1.2, 0.4. So from here R is equal to 0.4 by 0.8. You will get 0.5 ohm. That is the internal resistance of the cell. We got it as 0.5 ohm. Now we are asked to calculate the epsilon, that is EMF of a cell. We already studied EMF means internal current plus external, both we have to calculate. So I into epsilon or voltage, we can say both are same. E is equal to IR plus IR, or the same way just now we calculate V is equal to I into R plus R. Both methods are correct. Epsilon actually means the entire voltage. V is equal to I into R plus R. So here you can see I, current is already given 1.2. I am taking parallel combination. If you do the same with the series combination also, you will get the same answer. Now I am considering the first condition, parallel. Current in the parallel combination is I. I is equal to 1.2. Okay. So epsilon is IR plus IR, or we can write V. Epsilon is total voltage, or voltage is equal to I into R plus R. Current in the circuit is 1.2 ampere. Resistance in parallel is 1, and internal resistance we got 0.5. So when you calculate, you will get 1.8 volt. If the same way, if you calculate the resistance in series, V is equal to I into R plus R. I is 0.4. If you want, you may just check whether the answer is correct. If you are connecting in series, I is 0.4, and resistance, when two resistors are connected in parallel, it is 2 plus 2, 4. 4 plus internal resistance, we already got it is 0.5. So when you calculate this, 4 into 4 plus 0.5, not 4, 0.4. That is 0.4 into 4 plus 0.5, you will get 4.5. When you calculate this, then also you will get the answer 1.8 volt. Next question number 27. A battery of EMF 15 volt. EMF is given, that is internal and external all together. Voltage in this battery is 15 volt, and the internal resistance of the battery is 3 ohm. So internal resistance is 3 ohm. Is connected to two resistors, 3 ohm and 6 ohm, connected in parallel. So the battery is connected to two resistors, 3 ohm and 6 ohm, which is connected in parallel. Find the current through the battery, potential difference between the terminals of the battery, current in 3 ohm resistor, current in 6 ohm resistor. 4 sub questions are there. Anyhow, whenever we got a diagram like this, if these two are connected in parallel, the first one thing is to calculate resistance in parallel. 1 by Rp is equal to 1 by 3 plus 1 by 6. Cross multiply, you will get 9 by 18. So reciprocal, 1 by Rp is 9 by 18. So Rp is 18 by 9. You will get 2 ohm. So the entire resistance we got 2 ohm. Next is total resistance. How will you calculate total resistance? This resistance, this combination we got 2 ohm. We already have internal resistance 3 ohm. So total resistance of this circuit will be 2 plus 3, 5 ohm. I repeat, 2 is this combination of resistance, 3 is the internal resistance. So total resistance is 5 ohm. If we have total resistance and total voltage, we can calculate total current. I is equal to V by R. 15 by 5, we will get 3 ampere. First question. Second question. Calculate the potential difference between the terminals of the battery. These are the terminals of the battery. Terminals positive and negative. Between means from here till here. Okay, so internal resistance we have to neglect. That is between the terminals is not between positive and negative. From positive till negative. So internal resistance we have to avoid. So potential difference V is equal to IR. Current is already, we have the current is 3 ampere. Just now we got current 3 ampere and resistance 2 ohm. Why I took 2 ohm? Actually the total resistance is 5. But since it is given terminals of the battery, so the internal resistance, small letter r, is neglected. So we have to take only the resistance of combination in parallel. So 3 into 2, 6 volt. Next is current in R1. Current in the resistance R1 and current through resistance R2. I already told we already got 3 ampere current. So we got 3 ampere current. When it reaches here, it's split into I1 and I2. We don't know how much current will go through I1, how much current will go through I2. Anyhow, only 3 ampere will go. That 3 ampere is split into I1 and I2. We are asked to calculate what is I1, what is I2. Once we got I1 and I2, when you add it, again you should get 3 ampere. Okay, so for that, since they are connected in parallel, we have the new formula. Current in R1 resistor. R1 is R2 by R1 plus R2 in the current into current. So it is a new formula. Actually only this one problem consists of this model formula. Current in R1, that is we are going to calculate current in through that particular resistance. If you are asked to calculate current in R1, then the formula is R2 by R1 plus R2. If you are asked to find current in R2, then it is R1 by R1 plus R2. It's very simple. If you are asked to calculate R1, then formula is R2 by R1 plus R2 into I. That is current. How much current? The total current. A portion of that total current is going to through the resistance. Since resistance are connected in parallel, we are using this formula. Again, current in R2 is R1 by R1 plus R2 into I, total current. So we will substitute. R2 is 6 ohm, R1 plus R2, 3 plus 6 into 3. 3 plus 6 is 9. 9 and 3 get cancelled. So here 9 and 3 get cancelled. You will get total 2 ampere. The final answer will get 2 ampere. Then current in 2 R2, that is R1 by R1 plus R2, 3 by 3 plus 6. Here while cancelling, finally we get 1 ampere. So you got current in 3 ohm is 2 ampere, another is 1 ampere. So all together it is 3 ampere. We already got the current in the circuit is 3 ampere. So the total also it is 2 plus 1, 3 ampere. Okay. Next question number 28. You have to look figure number 8.53. It is clearly given. There is a cell. The EMF of the cell is given 2 volt. Just above the cell it is written 2 volt. And the internal resistance of the cell is given 3 ohm. And current from the cell is given 0.25 ampere. And 2 resistors are there connected in parallel. 2 ohm and R ohm. That is unknown resistance. And these 2 resistors are connected in series with another resistance 4 ohm. So that is the concept of that diagram. Now, the circuit diagram shows 3 resistors 2 ohm, 4 ohm and R ohm connected to a battery of EMF 2 volt and internal resistance 3 ohm. If the main current, that is the total current in the circuit, is 0.25 ampere flows through the current, find the potential difference across 4 ohm resistor. 4 ohm resistor is connected in series. So V is equal to potential difference voltage. V is equal to IR. What is the current in the circuit? The entire current is given 0.25 into 4 ohm. This 4. So 0.5 into 4 you will get 1 volt. Second question is potential difference across the internal resistance. So internal resistance is given 3 ohm. So potential difference across internal resistance is again V is equal to IR. Current is still constant 0.25 into internal resistance 3. So we will get 0.25 volt. Next is potential difference across R ohm or 2 ohm. Potential difference across R ohm or 2 ohm. Actually the EMF, the total resistance is given 2 volt. Okay, total resistance is 2 volt. Potential difference across 4 ohm is 1 volt and internal resistance is 0.75 volt. So we can use a trick that total 1 plus 0.5 is 1.75 across 4 ohm. I think you can see the textbook. Across 4 ohm. Here the voltage drop is 1 volt and through the internal resistance it is 0.7. Okay, is it clear? Here it is. Okay, here through 4 ohm resistance we got the potential difference is 1 volt. Through the internal resistance, through the 3 ohm, we got the potential difference 0.75. We already know the entire potential difference or EMF is 2 volt. From 2 volt, 1 volt and 7.5 volt is reduced. So, what will be remaining? 1 volt. From 2 volt, when 1 volt is reduced, remaining again 1 volt. Again from 1 volt if 0.75 is reduced. So, only remaining 0.25 voltage is going to enter the circuit. Okay. So here you can see the potential difference across 4 ohm and potential difference across 3 ohm is epsilon. That is 1 plus 0.5, 1.475 volt. Therefore, potential difference across R ohm or 2 ohm is 2. 2 minus 1.75. 2 is the total potential difference. From that, we are reducing 1.75. We will get 0.25 volt. So, potential difference across R ohm or 2 ohm is 0.25 volt. Now, the last question D. Calculate the unknown resistance R. If you want to calculate the unknown resistance, first we have to calculate the entire resistance of the circuit. In the question it is provided entire resistance, entire potential difference is given in the question. Entire current is also given in the question. So if both are given, we can directly calculate R is equal to V by I. So voltage is 2, current is 0.25. We got 8 ohm. 2 by 2.25 is 8 ohm. So total resistance. So again we are going to calculate the total resistance. Here there are 3 resistors, 3 resistance. Here you can see, here 3 ohm is the first resistance. Here 4 ohm is the second resistance. So 3 and 4 they are in series and these two are in parallel. Okay. So 3 plus 4 plus this is in parallel 1 by 2 plus 1 by R. So this I am writing here 4 plus 3 plus, since these are connected in parallel we have to take 1 by 2 plus 1 by R. 4 plus 3 7. 7 plus 1 by 2 plus 1 by R. Plus 7 taken to other side it will become minus 7. 8 minus 7. So 1 by 2 plus 1 by R is equal to 8 minus 7 1. So I wrote it again. 1 by 2 plus 1 by R is equal to 1. So what will be 1 by R? This positive 1.2. Take into other side negative 1.2. 1 by R is equal to 1 minus 1 by 2. 1 minus 1 by 2. From 1 if half is gone. 1 minus half is again half. So no need to convert into decimal. Let it be in fraction itself. So 1 by R is equal to 1 by 2. I repeat. 1 minus half is half. So 1 by R is 1 by 2. So what will be R? Taking reciprocal 2 by 1, that is R is equal to 2 ohm. That is our unknown resistance is 2 ohm. If you want, you can calculate the entire resistance in this formula. 4 plus 3 plus 1 by 2 plus 1 by R. This 2 when you substitute here, when you calculate, you will get the entire resistance as 8 ohm. Thus you can check your answer. Next question number 29. 3 resistors 6 ohm, 2 ohm, 4 ohm are joined to an ammeter A of a cell of EMF 6 volt shown in figure 8.54. Calculate the effective resistance and reading of the ammeter. So here you can see the diagram. From this diagram you are asked to calculate. It's better for you to look in your textbook. You can see the diagram. Here you can see this junction. From this we have to calculate the total resistance. So from this diagram, first you should know how to take the resistance in series and parallel. Here this is the junction. As I told, more than 2 connections. Here you can see this is one line, This is another connection. This is third connection. So the three wires connecting together. So this is one junction. This is also one junction. So all the resistors we have to take, in between is one and outside the junction is other. So this 4 and 2 is connected in series. So these two can be taken as series connection, 4 and 2. So the total is 6 ohm. This 6 ohm is parallel to this, because when you put a dot, we have to take from one dot to another dot in clockwise direction, one dot to another dot in anti-clockwise direction. So from one dot to another clockwise, these are connected in series. Here if you have one more circuit also, then this is connected in series. So this is connected in series, 4 plus 2, 6, and here 6 alone. So here you can see the total resistance 1 by Rp is equal to 1 by 6 plus 1 by 6, 2 by 6, taking the reciprocal. Cancelling, we will get 1 by 3. So Rp is equal to 1 by 3. So that is reciprocal, Rp is 3 ohm. So what will be the current in the circuit? So first question is effective resistance. Resistance we got 3 ohm. 3 ohm is the effective resistance. Now current in the circuit, I is equal to V by R. Voltage is given, it is 6 volt, it is given in the diagram, and resistance we got 3 ohm. So the answer is 6 by 3, 2 ampere. Next question number 30. The diagram below shows, that is figure 8.55, shows the arrangement of 5 different resistors connected to the battery of EMF 1.8 volt. Calculate the total resistance and reading in the ammeter. So again you have to look for the diagram. Here you can see these two are connected in parallel, 10 ohm and 40 ohm. So to calculate the total resistance, 1 by 10 plus 1 by 40. You will get the answer 8 ohm. The same way here 3 resistors are connected in parallel. So we have to calculate the resistance over here, 1 by 30 plus 1 by 20 plus 1 by 60. After taking the LCM, finally taking the reciprocal, we will get 10 ohm. So the total resistance is 10 plus 8, 18 ohm. And the voltage is given 1.8. You are asked to find current, I is equal to V by R. Voltage is 1.8, R is 18, total resistance. So this is the diagram. So when you are doing the problem, first look the diagram and calculate. So here you can see 1 by Rp, 1 by 30 plus 1 by 20 plus 1 by 60, taking the LCM, and finally we got Rp. And the second one is 10 ohm, and the first one here 1 by 10 plus 1 by 40, finally we got Rp is 8 ohm. So the total resistance 10 plus 8, 18 ohm. So total resistance of the circuit we got. Total voltage is given in the question. I is 1.8. So total current I is equal to V by R. 1.8 by 18. You will get 0.1 ampere. Our last question in this chapter, question number 31. A cell of EMF 2 volt and internal resistance 1.2 ohm is connected to an ammeter of resistance 0.8 ohm. Two resistors 4.5 ohm and 9 ohm are shown in figure. So here you can see the diagram. In this diagram you can see the voltage is given 2 volt. You can see near the cell. Voltage is 2 volt and the internal resistance is given 1.2 ohm. And the ammeter also shows a internal resistance. Internal resistance of the ammeter is 0.8 ohm. Okay. Here the battery have an internal resistance 1.2 ohm. Ammeter has the internal resistance 0.8 ohm. And here again 2 more resistors are connected in parallel. So you are asked to calculate the total resistance of the circuit. Total resistance means first we have to calculate the resistance of this parallel circuit. That final answer plus 0.8 plus 1.2 will get the total resistance. So here you can see 1 by Rp. First I am calculating the resistance in parallel. 1 by Rp is equal to 1 by 4.5 plus 1 by 9. Cross multiplying, and finally we get 1 by 3. So Rp is 3. 3 by 1 or 3. So total resistance is 1.2 plus 0.8 plus 3. you will get 5 ohm. So total resistance of the circuit is 5 ohm. So what will be the total current? Total current is equal to I is equal to V by R. Voltage is given the question 2 volt and total resistance is 5. 2 by 5 is 0.4 ampere. Now second question, the potential difference across terminals of the cell. Again, terminals of the cell means internal resistance of the cell should be neglected. From positive to negative, as I to explain in question number 27 or 28, I think. If you are asked potential difference across the terminal, you don't want to take the resistance of the internal resistance of the battery. So potential difference V is equal to IR. Current is 0.4 ampere. R, do you know why I took here 3.8? Because I am neglecting the internal resistance. Here the internal resistance is 1.2. Total resistance is 5 ohm we got. And from that we have to reduce this resistance of the cell 1.2. So 5 minus 1.2. It is 3.8. That is why I wrote here resistance as 3.8. So 0.4 into 3.8, you will get 1.52 volt. Now the last sub question is, calculate the potential difference across 4.5 ohm resistor. Again you are asked to calculate the potential difference of 4.5 ohm. Okay, so here you can see these two resistors are connected in parallel connection. So in this parallel connection, both resistors, you are asked to calculate the potential difference across 4.5. Okay, so you know when the resistors are connected in parallel, the resistance, total resistance we calculated it as 3 ohm. Total resistance we have to consider. That is why here you can see potential difference across 4.5 ohm. V is equal to IR. Current is still constant. I is 0.4 and R is 3 ohm because we already got when these two resistors are connected in parallel, 1 by 4 plus 1 by 3 ohm. This 3 ohm, if two resistors are connected in parallel, the total resistance will be the same. So you have to use here 3 ohm. So 0.4 into 3. So you will get 1.2 volt. So this entire chapter 8B numericals over. It's a lengthy chapter, 31 problems. Hope all of you understood all the problems. Thank you.